guys, this is Professor Janicek. I want to go over an application where we find the surface area of a three-dimensional object. So let's start with the function f of x, and if we draw the curve described by f of x, we get something like this red line here. And now what we're going to do is we're going to take that red line and rotate it about the x-axis, and what we end up with is a three-dimensional object, and we're going to just find the area of the outer surface of that object. Now, if we were to cut along that red line along the top and unroll it, we get something that looks sort of like this rectangle down below. And what we need to do here is find the area of this rectangle-like thing. That's the surface area of our original three-dimensional object. So that's all we need to do. Find the area of this rectangle-like object. Well, we know how to find the area of a rectangle. The area of a rectangle is simply length times width. Looking a little closer though, what is that length? Well, that length here really comes from this circle. It's the circumference of that circle. So our length is the circumference, and the width would be the length of our curve f of x. So our surface area is length times width, but the length is the circumference and the width is the length of the curve. That's what we need to remember. Surface area, length times width, but the length is the circumference, unrolled circle, the length and the width is the length of the curve. All right, let's see how we write that mathematically. Well, I'll use S for surface area. Now, circumference, remember, is 2 pi r. But what is the r in this case? Well, the radius of our circle, if we go back and look at this circle, the center of it, in this case, is the x-axis, and its radius is how far it is to get to the function. Now, if our circle happens to be in a different spot, so suppose I'm looking at a circle, say, over here, then the radius would go from the center up to the top, or from, again, the x-axis up to the top, depending on where we are. But no matter where it is, it's always that y value or that function value. So, moral of the story, our radius is always the function value. All right, that's not so bad. And then the length of the curve, we had gone through this before. There is a formula for that one as well. It's the square root of 1 plus f prime of x squared. Of course, we will need to integrate this, and we're going to integrate with respect to x in this case. Also, we'll go ahead and define some x values, where to begin and where to end. We'll go from a to b. Now, of course, this is in terms of x. We could also do this in terms of y. If our function, I'll call it g, is in terms of y, then our function is, our formula is very, very similar. We're just using g of y and integrating with respect to y. And there you go. That's the formula. Again, I don't recommend that you just memorize the formula. It's probably best to remember where this formula comes from, that it's length times width, which is circumference times the length of the curve. And then just looking at the picture, where do those things come from? Let's try an example. Let's find the area of the surface generated by revolving the function f of x equal to 2 squared of x about the x-axis on the interval from 1 to 3. I've already graphed this, so take your time. Make sure you know how to get this graph on your own. So let's see. We have our function f of x, 2 squared of x. And since this is in terms of x, we want to integrate 2 pi f of x times the square root of 1 plus f prime of x squared dx. All right, so in this formula, I know I'm going to need f, which I've got, and I'm going to need f prime squared. So let's see, what is f prime? Well, in order to find f prime, it might be easier to look at f as 2 times x to the 1/2 power. Then we could use our power rule and we get x to the negative 1/2. Not real crazy about dealing with negative exponents, so I'm going to go ahead and write this as 1 over the square root of x. Our formula says that we need f prime squared, so let's go ahead and square this. And we end up with 1 squared, which is 1, square root of x squared, which is x. So we just get 1 over x. Well, that's not so bad. Okay, so back to our formula to find the surface area, we're going to integrate. In this case, our x values go from 1 to 3, so we're going to integrate from 1 to 3, of 2 pi times f of x, well, that's 2 square root of x, times the square root of 1 plus f prime of x squared, well, that was just 1 over x dx. All right, let's see. We can do a few things. I'm going to go ahead and factor out the two 2's and the pi. So that's going to give me 4 pi times the integral. Still have the square root of x, still have the square root of 1 plus 1 over x in that integrand. All right, I think I can actually clean this up a bit more. Let's go ahead. There are a couple of ways of doing this. I'm just going to go ahead and distribute. I'm going to take this x and distribute it into the second radical. They're both radicals, so I can go ahead and put them both in there. So that's going to give me the square root of x times 1 plus 1 over x. And if we do that distribution, we get the square root of x plus x times 1 over x. Well, that's just 1. Well, isn't that nice? So we're simply going to integrate the square root of x plus 1. Now, in order to do this, we'll want to do a substitution. If we let u equal to x plus 1, then du is simply dx. And you'll notice what we're integrating. Notice here is u and here is du. So we're going to integrate the square root of u du. Integral of the square root of u du. Well, that's the integral of u to the 1/2, which ends up being, let's see, 2/3 u to the 3/2. Now, I worked with u off on the side. I'm actually going to go back and just work in terms of x's. I hope after a while of working with those u substitutions, you can do this easily as well. If you're not comfortable with it, though, go back and practice that u substitution. So I'm not really going to change to u's. I'm going to keep this in terms of x's. So we end up with, we still have the 4 pi out in the front. This is 2/3 times u, which is really x plus 1, raised to the 3/2 power. And we're going to evaluate this from 1 to 3. And there you go. I'm going to go ahead and let you guys have the fun of evaluating that. We've done the calculus. I'll let you guys do the arithmetic. You should end up with 16 pi over 3 times 4 minus the square root of 2. There are other ways of writing it. This is the form that I wanted to end up with. So just make sure you know how to get there. You'll also notice that there are no units on this, although this is an area. So if we did have units, of course we would have the units squared for our final answer. Enjoy!